Okay, so let's move the last problem up a little bit. So now we're going to find the area of the part of the plane 5x plus 2y plus z is equal to 10 that lies in the first octant. So we're going to have 5x plus 2y plus z is equal to 10. And we want to find the part of the plane that's in the first octant. So if we think about what the first octant looks like, right? The first octant, really there are 8 of them, but if we think about the first octant, it would be this area that we're used to seeing whenever we look at a 3D Cartesian plane, and it would be this little cube right here. Not so this would be the other octants behind it and under it, right? But we don't want to consider those. We just want to consider everything that is in this area and going up, right? So that is the octant that we're considering. Okay, and that means that we have some certain constraints. So we know that x is going to be greater than 0. We know y is going to be greater than 0. And we know that z has to be greater than 0. Okay, so firstly we should, before we know we're eventually going to be integrating, and we want to put this equation here into a form that we can integrate. So we want to put it in a form of a function of x and y. So by subtracting 5x and 2y on the left side to the right, we get z is equal to 10 minus 5x minus 2y. Alright, so this is basically our f of x, y, and we know we're going to be integrating with respect to x and y. So we also have to come up with our bounds. So for this case, we want to set one of our bounds to be constant and one of our bounds to be variable, depending on the other variable. So let's say our x is constant, right? So if our x is constant, then in order to suffice this, and in order for z to be greater than, or I guess it's greater than or equal to 0, right? Because if we are at this point here, it's still in the first octant. So greater than or equal to 0. To suffice this condition, we have to say that x is an element from 0 to 2, right? So these are the bounds on x. And then when y is going to be our variable, we can say that y ranges from 0 to a function of x. So it ranges from, let's say we were to write this as, I'm running out of space here, so 0 is equal to 10 minus 5x minus 2y. So this is the line representing how y varies. If we are to add 2y to this side and divide by 2, we would get y is equal to 5 minus 5 halves x. So this is y as a function of x, and this would be how y ranges. So these are the bounds. Now, whenever we're talking about a surface area of a plane, um, there is a certain equation or a certain integral form that we use. So just to make sure, so let's say this is our surface. Normally, I believe it is the partial derivative of x squared plus the partial derivative of, well, hold on, I'm sorry, one second. So it's the partial derivative plus, with respect to x, partial derivative with respect to y plus 1, and then over your surface. So let me just make sure here. So that is how it's done in this case. And also, we want to define what our partial derivatives are. So so in this case, this is our function f. So the partial derivative with respect to x would be the derivative of minus 5x. You treat the other terms as constants, so it would just be minus 5. And our partial derivative with respect to y in this case would be minus 2, because you treat this as your variable term and these two terms as your constants. So you would get minus 2 in this case. Alright, so plugging these values in, we get So first let's put our bounds. So we want to integrate over the variable bounds first. So 0 to 5 minus 5 halves x, 0 to 2, and then we know we're going to have dy first and then dx, right? So we are going to plug in f of x. We're going to get square root of minus 5 squared, and then our partial derivative with respect to y is minus 2, so minus 2 squared, and then plus 1. So we're going to rewrite our integral here. So we know that this is going to be square root of 30, and because square root of 30 is a constant term, we could take it out of the integral, and let me just make some space here. We could take it out of the integral, and we can differentiate with, not differentiate, sorry, integrate with the same terms here, and we're just going to be integrating 1 with respect to y and x. So after integrating with respect to y, we get 0 to 2. The integral of 1 with respect to y is just y. And we get 0. Our bounds are 0 to 5 minus 5 halves x. And now because we have a 0 bound here, we only evaluate our upper bound. So we get 0 to 2 of 5 minus 5 halves x dx. So our integral is pretty simple here. So integral of 5 with respect to x is 5x. Integral of 5 halves x is 5x squared. Oh, I'm sorry, it's minus 5 over 6 because, wait, nope, it is, it's 5/4, my bad. So it's minus 5/4 x squared, alright? That should be it. And then we're going from 0 to 2. So at 0, the whole thing is 0, so we only evaluate our upper bound. So we get 10 minus, here x squared is 4, so we get 5 times 4 over 4. These 4's cancel. We get 10 minus 5, and that gives us 5. And let's not forget that we had this square root of 30 on the outside here. So if we carry it over through all of our computations here, we add that square root of 30 here, and we get that our answer is 5 times square root of 30. And that is what was gotten here. And then in terms of units, yeah, this written response here has units squared. I'm guessing, yeah, it would be in terms of units squared. Okay, so that is the correct solution. Good job. All right.